Now we'd like to request all our presenters to come back onto the dais so that we could have the question answer session as well as some interaction. I'd also like to invite Mr. Teddy D'Souza to come onto the dais as well. He is the operations head, India and South Asia for Knopf EMF. So I request all of you to come back on stage.
Is this okay? Yeah. First of all, I will start by continuing where we stopped. So my apologies for being a little bit aggressive, but I have a key point on NRC, and this is fighting against the industry. You know, we created this big demon called NRC, and now what the industry is really doing is trying to tell you that the 0.7 is cheaper than the 0.8. 0.8 is cheaper than the 0.9. 0.9 is cheaper than the 1. Little do they understand that NRC does nothing for the customer at the end of the day. It's only for comparison of two products to bring it to one line, which is actually law of averages. So if I have to make a small joke about the law of averages, I always explain it like this. If you put one leg in boiling water and the other leg in cold water, on an average you should feel comfortable.
Good one.
Yeah, but it doesn't work like this. It really doesn't work like this. You will feel very uncomfortable. Trust me, try it. Okay? So, having said this, we are taking 4 different frequencies, adding it, dividing by 4, and then saying on an average this product is 0.7. I want to bust this myth on this platform. Please don't get drawn into this argument at all. Turn the product, look at the graph. If you are getting a straight line, this product is very good for that NRC. You try to select the product which has a straight line. All those products which start from the bottom here and end up on the top there and say, I am 0.9, are really taking you for a ride. Just look at the graph, look at the octave frequencies, just catch the one which says straight line. To make it simple. Now the question comes of whether I want a 0.9 or a 0.7. So this brings me to your presentation, where I was just a bit scared 75% of the time, but I became a little happy in the last 25% of the time, because you finally use some silly product. So there is still some scope, it's not ending here. Okay. Having said this, privacy in open spaces is an art. I would like to give a few sentences about the Lombard's effect. If you sit in an open space, this is the best place to create privacy. For example, if you want to discuss a big contract, the best place to discuss this big contract is in a private place, because you don't want anybody to hear about it. Take a guess of which is the best private space you would want to discuss this contract.
On the terrace where we designed the restaurant.
In a restaurant.
McDonald's! McDonald's, not in your office. If you do it in your office, the next guy is clearly hearing you, because the insulation levels are not even thought about. They're not thinking about insulation levels. We are thinking about a 0.9 and a 0.7. But what does this do to me? Yeah, you must be the greatest manufacturer on earth, but what do you bring on the table for me is a question that we always need to answer in acoustics. I was at the town hall 2 days back. Amazing place, because I could not find acoustic anywhere. We are always searching for this. No?
There.
Yeah, I know. I saw it in a presentation. Okay, very good. But what we need to.
And don't tell me they're bad.
No, what we need to know, it was a good job.
You can tell me outside, don't
It
you?
was a good job done. But what we need to think of is that there has to be a level where you have to stop the Lombard's effect. Okay? Because if I want to talk to you and the place is too noisy, then I raise my voice. If I raise my voice, the next guys on the table raise their voice. And then the next guys are raising their voice, and we are all talking over each other. The end effect is this place is not very good at all. To cut this off, you need some amount of acoustic elements to be installed, and this is what exactly you did.
Absolutely.
Yeah.
They are must.
You not overwhelm the place because it will not be a restaurant anymore, it will turn into an office. But at the same time, you tweak the place by putting.
But as you very rightly said, that which is the best place to do negotiation. And as he said, the office is a new fun place, a club and all that. I said the reverse. I said restaurant is a new workplace. That's where you do your networking, that's where the brilliant ideas come to you, that's where you enjoy, and a free mind is when you are creative the most. Free mind is where you actually, your best interactions, your best thought processes, things happen to you. So for us to do, as I said, we do plethora of a wide range of projects, but to do a restaurant is, and I hate going to a restaurant which is beautifully chic design, but as I said, starting my presentation, the background chatter kills the whole ambiance. It's not visible, visually you're seeing everything so beautiful, but you're not comfortable. So acoustics is most important. When I said we stretch ourselves not to go into the typical ways of using it, but yes, where we have to, we have to. The second point that you're making is that the insulation within the workspaces and all that, and trust me, we are all aware of that. So when we are doing those private meeting rooms, we are doing conference rooms, we are doing the chambers for the top management, we make sure partitions go all the way up. We make sure that air conditioning is independent, there are no ducts going from one room to the other room. We make sure the flooring is sound absorbent, the ceiling is sound absorbent, the walls are sound absorbent, as far as possible. And because it is critical, I mean, as I said, the next guy over here what you're saying. He may be your most trusted employee or friend or colleague or anything. He could be a competition tomorrow, of course. So the secret is only a secret as far as only one person knows it. So I think I say it for everybody in the design fraternity. We are very, very aware of it, and we may laugh about it, we may joke about it, but we take it very seriously.
In fact, there was one more case. We were doing a study of a factory, and we came down to the fundamentals which we know, but we don't apply in acoustics. Did anybody try reading a newspaper when your television is yanked up or the volume is high, and you're sitting right in front of this television and trying to read a newspaper? Did you ever try? If you haven't tried, your senses cannot concentrate on two things. Eventually you will shut off one. Either the television goes off or you drop the newspaper. 3.5 minutes it seems is the limit. If you are maybe you are thinking that you will never get this newspaper again. I have to read this article, then you stick to it maximum 3.5 minutes. Otherwise you give it up in 33 seconds. Max. This can happen if your child is yelling around in the house and the TV is working. Either you allow the child to continue, shut off the television or throw the child in the next room. You cannot get on with this anymore. And this is one thing we discovered in insulation between rooms. There are customers who are complaining, I can hear something. But don't give too much of importance to this. Something is always nothing. Because as far as you cannot decipher what he is speaking, your mind will never go there. The moment you decipher and you can clearly identify what he is saying, that's when you get distracted. Therefore, the cost competitiveness of using a product to insulate should go just to the level of a murmur. Then, over and above, if you try to plot this cost on a graph, it becomes extremely high to completely block the sound. Yeah. So, we are, as manufacturers, always trying to concentrate on this dB value. And this is the problem when I said about NRC. So, I am coming full circle when I make this point that the 0.9 purely depends on letting noise pass through it. If you see this product, it's light, it's got no density. It's just depending on noise to pass through. When it passes through, it hits the soffit on top. What do you think happens to it? It goes into the next room flanking. The graph, the picture which you showed, goes into the next room. So you put a noise, you put a nice reverberation control in this room, but you're passing all the noise into the next room. And the next room can be heard in this room. So we are always trying to look for products to build in a 0.9, which will control the reverberation probably in this room, but at the same time have a dB value to ensure that it cuts off sound from going to the next room. And this combination is difficult to produce, understanding the fact that to make a very high sound absorbing product, it has to be very porous, and at the same time, to stop sound, it has to be denser. And this is the technology that AMF uses to have the mineral board in a 0.9, not only to allow enough sound to pass through, but at the same time have a decibel value of cutting sound by 28 or 30 decibels.
I agree with you. Ultimately boils down to the dB level. But why we have to take a reference somewhere. When we're talking about NRC, we have to take a reference somewhere. So I take it in a different way, slightly different way. That there are two important aspects. One is the absorption and other is the insulation. So when we're talking purely about the NRC, so I take more of an absorption method, which helps me in the reverberation time and the speech intelligibility within the room. Then next comes the isolation, the transfer of sound from one room to other room. So that's where the STC comes in. We have a wall there in between, or we have a door in between, or a partition in between. So what is the STC value it removes? What is the sound level it prevents, from crossing to the, getting propagated to the, through that wall or the door to the other room. I'll just quote you an example. It's about maybe 10 years back. I had a chance to work on a project wherein it was a big corporate house. They wanted to have a video conferencing room. The video conferencing was becoming very popular those days. It was catching up, and unfortunately, the architects or the interior guys, they wanted to make it in the center of the hall, and it was mostly there was 90% reflective surfaces used. So what they did, they made a cubicle, they made a full height glass, and it was quite thick glass. Inside they used the best of the marbles. They had Italian marble. The table inside, that was again a very hard surface, it was a glass. And ultimately, when they made it, and they then started the video conferencing session, they found that the far end, they could hardly understand what these guys are saying. So that's where the problem started, and then they called the people, they had hired an integrator for installing the video. The video conferencing guy said that whatever integrators you have done, so probably they might have indicated them in the beginning that you shouldn't use glass and other things. But they wanted to have it, they wanted to give a better look and all. So ultimately it went to the extent that they had to, the corporate house, they had to sue the video conferencing company just for a small thing, but they were not ready to understand that they are using totally reflective surfaces. That's where there was a lot of isolation. To the glass, they used the BGU and other things. There was a lot of isolation here, but there's no absorption. So whatever sound was inside, it was creating echo, and despite having an echo canceller also within the system, within the video conferencing system, still the far end couldn't perceive much what they've seen. So that's what I feel that the NRC ultimately, as you said, you rightly said, so 0.9, 0.8, what it should be. So there has to be a reference somewhere wherein we consider, okay, this is a product which has been tried, tested, lab tested for the absorption. So you know that, okay, the echo, or even when we do it, when we simulate it on the software also, there again, you feel the kind of material or even the values, the NRC value. So that gives you an idea about, what, when you're ultimately making the room or the space. So how it should come out, the sound, how it should come out, how much echo or the speech intelligibility, SDI. That was my point.
I think it's time for you to come to stage now.
Any questions? Any other questions from the audience? Any other discussion?
Yeah,
just want to ask a very simple, very basic. It's okay.
Yes.
Thanks. Hello. A basic question. Every object or every living thing is generates sound. Human being also generates sound, and it also absorbs. So when we do acoustic calculation, how do we treat a human being? As a sound generator,
Very fundamental question.
and also as a absorber, because a human being is a absorbing body and also emitting sound.
I would say that human being, instead of, we consider it as a sound generating or sound producing. So when we calculate, when we design things, we always see that what is the seating capacity apart from the cubic space which is available, the room size. We see that what is the seating capacity, and in those terms, the human bodies act as absorption rather than generation. Of course, there is a minimum noise which will always be generated. That's where the NC comes in, noise criteria comes in. For example, if it's a meeting room, so we always consider it maybe 20-seater, 30-seater meeting room. So we consider that, okay, NC 30 could be the value which we have there. So we have to always take a reference somewhere. So we consider about 37 dB of sound which nobody is talking anything on even on the HVAC grill. You find we have about 30 dB sound generated. Under the ideal condition. So we have to take a reference somewhere, wherein the human beings inside are considered as absorbers. If you actually practically see in an open room and suppose there is less of absorption, we don't have much of absorption on the walls or on the ceiling. Even then, if the room is empty, so there's a lot of echo. There is some echo which is generated, and when only the human beings, suppose there are 50 people inside the room, so the echo gets down drastically. That's where the absorption comes in from.
Till they're on chatting on cell phones to other people, then
No, I was just going to say, unless of course you're in Hong Kong and the honkies keep talking all the time, so in that case, there will be a noise generator, not a noise absorbent.
and you can't even understand what they're saying, so it's not even interesting gossip.
In a Chinese restaurant, for example. Go to Hong Kong, in a Chinese restaurant, you cannot talk. You can never have a conversation. I think that's about it.
Yeah. Great. Thank you all on behalf of Kanauf EMF and Buildotech. I'd like to thank our delegates here today, our presenters, for this wonderful interactive discussion. And I'd like Mr. D'Souza to hand over a small token of appreciation to our presenters today. In any particular order.
Thank you.
Thank you. Also, there is a wall of fame at the back there, so I request you to sign that with your comments. There's a red board there, and all the other delegates to also put your comments on that. That would be quite informative and good. And after that, of course, you are now welcome to please join us for cocktails and dinner and continue this discussion as we go through the evening. So have a wonderful evening. Thank you.